Okay, so in this problem 25, we want to find a unit vector in the same direction as A and in the opposite direction as A. So let's think about for a second what a vector is. A vector can be thought of as the linear combination of an I hat and a j hat. And let's say we have this vector over here. This would be if this is vector A, we would have the x component here, and then we would have the y component here. So if I want to make this 1, what I would do is I would divide by its magnitude, right? Because if I have a 5 and I want to make a 5 1, what do? I divide by 5 and I get 1. So I want this vector over here, but I want to preserve the direction. And to preserve the direction, I basically want to preserve this angle. Well, guess what? When you're multiplying or dividing by a scalar in a vector, you're constrained to this line over here. You can stretch that vector, you can shrink that vector, you can flip it if you multiply by a negative scalar, but you're going to stay on that line. So as long as we multiply by a scalar, a vector, that's fine. And then we realize that this small unit A hat here will shrink these sides to a similar triangle, so it will preserve this direction right here. And so if I find the number that I would divide this magnitude by in order to get A hat, I can just apply it to these sides, and they will preserve the angle because they will create a similar triangle. So that's what we're going for. So now let's get to work. First, see if you can do it by yourself. Okay, now we'll do it together. Now we have our A, and we know, based on the discussion that we just had, that the A hat, which is a unit vector in the direction of A, is going to be equal to the A vector divided by the magnitude of the A vector. Now, what is the A vector? Well, the A vector is 2, 2. And the magnitude, remember, we have just applied the Pythagorean theorem, so the magnitude is going to be 2 squared, the side squared plus the other side squared. And the result is going to be what? It's going to be the square root of 4 plus 4, which is the square root of 8. Now remember, we don't really have on the numerator the, say, the magnitude that we're trying to divide in order to get 1. But we have the sides, and we know that they'll be scaled accordingly, and so that they'll preserve the direction of the original A vector. Now, what if we want this same unit vector in the opposite direction? Well, we'll call this A up. That's just going to be the negative of that original unit vector. Why is that? Well, because we already saw that the effect of multiplying by a negative scalar is to flip the direction. And you should realize that that's the case even if you just think about just scalars. If this is 0 and this is 2, and I multiply 2 times -1, I'm still at 2, only now I'm on the left of 0. So we're changing direction in both cases. I hope you liked this problem. I did.